Next, SCANLINE fill for curved area. So requires more works than polygon filling with the non-linear boundaries. So we calculate the SCANLINE intersection and fill all the interior points. So symmetries between the quadrant can be used to reduce the calculation. So fill the region starting from the interior point until the appropriate color boundary is reached. There is two ways. There is a 4 connected and 8 connected. See, this is the 4 connected. This is the 8 connected. Okay. So wide boundary fill of int x y int b color int fill color value of get pixel of x comma y and value not equal to b color and value not equal to fill color. So put pixel x comma y fill color boundary fill 4 x plus minus 1 comma y comma b color fill color boundary fill 4 plus x plus 1 y b color fill color boundary fill 4 x comma y minus 1 and boundary fill x comma y plus 1 comma b color comma fill colors. So using of the 8, we can use the 8 boundary, that is x minus 1, x plus 1, x comma y minus 1, x comma y plus 1, x minus 1, y minus 1, x plus 1, y plus 1, x plus 1, y minus 1, x plus 1, comma y plus 1. So likewise we have to draw the boundaries. Okay. Next. Next, primitives. That is the attribute of primitive. There is a line attributes, curve attributes, color and grayscale levels, area fill attributes, text and characteristics. Okay. So the way a primitive is to be displayed is referred to as an attribute parameter. Some attributes parameters include color, size, etc. Different ways to incorporate attribute changes, that is, extend the parameter list associated with each primitive, maintain a system list of current attribute values, and use a separate function to set the attributes. So there is a different type of the attribute of the type, width, color, pen, and brush. Type solid, dotted, dashed, and dashed lines. There is a line types. That is a very short dash with spacing equal to or greater than dash itself. Dashed line displayed by generating an integer dash spacing dash dot combination of the earlier two. To set line type attribute in PHAG's application, set line type of IT can be used. LT can be -1, comma 2, comma 3, comma 4. So raster line algorithm displays line attributes by plotting pixel spans. Pixel count for the span and interspan length and interspan spacing can be specified using the mask. That is 11100. So there is a masking. Already we are discussing the computer organization. What is the mask? What is unmask? Okay, here only using the binary values, that is only ones and zeros. Okay, plotting dashes with a fixed number of pixels results in unequal length dashes for the different line orientations. So whenever the horizontal line looks small when the compared to the vertical line. So for dashed lines to remain constant, we should adjust the pixel spanel count for the solid span and interspan according to the slope of the line. So specify the pixel in the proportion of the standard width. Thicker line can be produced by there is adding extra pixel vertical when m less than 1, adding extra pixel horizontal when m greater than 1. We can set the width of a line using set line width scale factor of LW, where LW is assigned a positive number. Then use of line have different thicknesses. Slope problem, end of the line, there is a using of the line caps. Joining the two lines, there is a polygon. So this is the problem is different of the thick lines. Okay, in the raster line slope m greater than 1, then width of the parameter is 4. Like I said, you have to assign the only 4 lines. Okay, plotted with the horizontal pixel of the spans. See, line caps are used for adjusting the shape of the line and to give them a better appearance, there is a line end caps. Various kinds of line caps used butt cap, round cap, projection cap. This is the difference. This is a butt cap, this is the round cap, and this is the projecting caps. Okay. And also we have the different of the join. There is a metal join, a round join, bevel join. So metal join causes the outside corner of the stroke to come to a sharp point, causes the outside of corner of the stroke to come rounded the smooth curve, causes of the corner so that the width of the stroke is the same and the bevel as on the rest of stroke. This is the like as a metal join, round, bevel. Okay. Next, pen and brush option. The selected pen or brush determine the way a line will be drawn. Pens and brushes have size, shape, color, and pattern attributes. Pixel masks append to both of them. So, pen and brush options are mainly used from the painting. This is one of the example of painting. This is one of the example of the painting. So using paint and brush operations, we have to design the different of the operations. In that, there is a paint. There is a Microsoft Paint operations. We have different operations. These are the 502 image, color help. These are all the different of the tools we are playing. We have to design the different of the brush operations. Here we can define the different of the brushes. These are one brush like we have defined the custom document brushes, and also we have the number of brushes is available in the particular options. Next, polyline procedure, line color. That is, a polyline procedure displays a line in current color by setting this color value in the frame buffer at pixel locations along the line path using the set pixel function. That is, set polyline color index of LC. A line drawn background color is invisible. Curve attributes similar to line, that is time plus width. Thicker curves can be produced by plotting additional pixel, filling the space between two concentric circles using thicker pen or brushes. See, these are the options: thicker, thinner, like that. Okay, these are thicker pen, these are thinner pens. Okay, using all that we can draw the different of the circles, lines, curves, whatever may be. Okay, so these are curve attributes. Likewise, we can draw the curve attributes. Okay. Next, color and grayscale levels. So, general purpose raster scan systems provide a variety of colors while random scan monitors provide a very few. Colors are represented by color codes which are positive integers. Color information is stored in frame buffer or in separate table and use pixel values as index to the color table. There is the two way to store the color information, that is direct and indirect. See, this is code 0, red 0, green 0, blue. There is a black, 1, blue, 2, green, 3, cyan, 4, red, 5, magenta, 6, yellow, 7, white. Okay. So this is a color lookup table. Based upon color lookup table with the 24 bits per entry associated across the frame buffer with the 8 bits per pixel value. A value of 190 is stored at pixel position x, y references the location in this table containing the value 2081. In each 8-bit segment of this entry controls the intensity levels of the one of the three electron guns in the RGB monitor. This is a lookup table. This is a 196 value. That value will be assigned on that person. Based upon that, we can assign the red gun, green gun, and blue guns. Okay, this is the color lookup table. The lookup table has a 24 bits per entry, which is every of its entry buffer with 8 bits for each pixel. Okay, that will be 196 of the 196 values stored in the each of the pixel position, that is an x and y. That represents the location of the table containing the value of 2081. This is a 2081. There is a three guns are assigned. That is the RGB monitors. Okay, so based on these type. So zero is blue, black. One is blue, two is green, three is cyan, four is red, five is magenta, six is yellow, and seven is white. Next, grayscale. Apply for monitor that have no color. Shades of gray, white, light gray, dark gray, black. Color codes map onto the grayscale codes. 2 bits can give 4 level of grayscales. 8 bits per pixel will allow 256 combinations. Dividing the actual code with 256 will give range of 0 and 1. Color coding color display is 118 to map the nearest grayscale, then 118 by 254 0.45. There is a main light gray pen will be assigned to the light gray. See, intensity code 0 is a black, 33 dark, 67 light gray, 1.0 white. Okay, so based upon that, we assign the grayscale colors from the each and every lines or um, pics, images, whatever may be. Its area fill attributes. Option for filling a defined region is whether solid pattern and colors. Fill style. Three basic fill styles are hollow with colored border, solid and patterned. This is the hollow, color, solid, and next one is the patterned. This is the pattern, hollow with color, solids. Okay. So a basic fill style can be assigned PH. There is a PHH is already discussed on the first unit. PHH is program using the following function, that is sent interior style of fs, where fs can be hollow, hollow, solid or pattern. So another value for fill style is hatch, which is used to fill an area with the selected hatching patterns. Diagonal hatch fill and diagonal cross of the hatches. So the color for a solid interior of or for a hollow area outline is chosen with set interior color index of FC, where FC is the desired color code. Other fill options include specifications for the edge type, edge width, edge and color of a region. So pattern fill, we select fill patterns with the set interior style of index PI, where PI specifies a table position. For fill style pattern, table entries can be created on individual output devices. Set pattern representation of WS, PI, NX, NY, CP, where PI is pattern index number, WS is workstation code, CP is the second array of color codes with the NX columns and NY rows. Okay. The next one is the aliasing. So what is an aliasing? So in computer graphics, the process by which smooth curves and other lines become jogged. That is, the resolution of graphics device or fill is not high enough to represent the smooth curve. So whenever we can draw the lines or graphical representations or curves or whatever may be images, whatever may be, we can assign the jogged, that is the sum of the shades, some of the not clear, because of it is called as jogging. That means of the resolution is very low, the resolution is low or very low, the particular curves or lines will be jagged. Okay, that way you can say, because the resolution of the graphic devices or file is not high enough to represent the smooth curve. So actually when you have to draw the line, or it may be smoothly, but when maybe from the jagged or small dots like that, it is called as a jagged. Okay, because of it is there is no high resolutions like that. Okay, next, in the line drawing algorithms, we have seen that all rasterized locations do not match with the true line, and we have to select the optimum raster locations to represent a straight lines. Okay, when you can draw the line algorithm, we have seen that all the rasterized locations do not match, because of when you have to draw the line, all the lines not be matched. Some of the lines are upper, some of the lines are bottom, some of their borders like that. Okay, in that way we have to select the optimum raster. In that way, which is the perfectly raster line is there, that line will be selected, we can draw the lines. Okay, so in the line drawing algorithms, we have seen that all rasterized locations do not match with the true line, and we have to select the optimum raster locations to represent a straight line. This problem is served in low resolution screens. In such screens, line appears like steps likewise. So this effect is known as aliasing. It is a dominant for the lines having gentle and sharp slopes. So whenever all the lines are steps, shades, whatever may be, all the lines, that concept, that line, all called as the aliasing. That effect is called as aliasing. Okay, because of the resolution is low. See likewise. So this is the effect. Next, the aliasing effect can be reduced by adjusting the intensities of the pixels along the line. So when the aliasing effect will be formed, in that way what we have to do, we have to reduce the intensities values. Then pixels of the intensity values we can reduce, we can find the perfect lines. The process of adjusting intensities of the pixels along the line to minimize the effect of aliasing is called anti-aliasing. So the process of adjusting intensities of the pixels along the line to minimize the effect of aliasing is called anti-aliasing. So the aliasing effect can be minimized by increasing resolution of the raster displays. So by increasing resolution and making it twice the original one, the line passes through twice as many column of pixels and therefore has twice as many jogs, but each jog is half as large in x and y directions. So whenever we have to form that one, that is the aliasing effect can be minimized by increasing the resolution of the raster displays. See here. So in the before diagram, this is the 2 3 3 3, but here see to because of we are taking only what are the rasterized lines, that lines will be selected, the remaining will be discrete. But go from here, we can increase the points, then it will be perfectly we can assign the line. See, effect of aliasing with increased resolution. When we have increased the resolution, automatically we can get the perfect of the particular lines. Okay, but before you see that, likewise, but when we can reducing the resolution, that is increasing the resolution, we can get the perfect lines. See here, likewise. Okay, see, as shown in the figure below, lines look better in twice resolution, but this improvement comes at the price of quadrupling, that is increasing. So quadrupling means increasing the cost of memory, bandwidth of memory, and scan conversion of the time. So we can get the better lines. It will be depend upon the memories, cost of high memories, bandwidth, scan conversions. Okay, the next, thus increasing resolution is an expensive method for reducing aliasing effect with raster systems that are capable of displaying more than two intensity levels, that is the color and the grayscales. Okay, when we can apply anti-aliasing methods to modify pixel intensities by appropriately varying the intensities of pixels along the line or object boundaries, we can smooth the edges to lesser the stair step or jogged the appearances. Okay, so based upon that we can define the particular values. Okay, so with the raster system that are capable of displaying the more than two intensity. So what is that intensity levels are the gray and gray color and gray, also are the gray and sorry color and gray scales. Okay, already we discussed this, color and gray scales. Okay, we can apply anti-aliasing method to modify the pixels. Okay, so by appropriately varying the intensities of pixels along the line or object boundaries, we can smooth the edges to less than the stair step or jagged appearances. Next, anti-aliasing methods are basically classified to the first one is the super sampling, next one is the poster sampling. Okay, next, super sampling. So what is super sampling? Super sampling or post filtering is the process by which aliasing effects in graphics are reduced by increasing the frequency of the sampling rates and then averaging the result down. Okay, this process means we can calculate a virtual image. So based upon the virtual image, we can calculate how it will be assigned, how it will produce the image. Based upon that virtual images, we can create our own images. Okay, so this process means calculating a virtual image at the higher spatial resolution than the frame store resolution and then averaging down to the final resolution. It is called post filtering, as the filtering of carried out the after samplings. So based on the virtual images we can define, before we can identify that how you can draw the images, how can you assign the particular areas like that. Okay, in that way it's called as the super sampling or post filterings. Okay. Next, super sampling is basically a three-stage process. Whenever we apply the super sampling, it will be based upon the different of the stages. Mainly, we can define the three stages. First one, a continuous image, that is L of x comma y, is sampled at n times the frame resolution. This is a virtual image. The virtual image is then low pass filtered. Okay, then we can filter that image is then resampling at the final frame. So based upon the sampling images, that is the virtual images, we can define the different phases, then apply that phases, we can filter the images, then we can resample that final frames. Okay, so that we can get the final images. Next, what is area sampling or pre-filtering? In this anti-aliasing method, pixel intensity is determined by calculating the areas of overlap of each pixel with the object to be displayed. So, anti-aliasing by computing area is referred to as area sampling or pre-filtering. A modification to Bresnam's algorithm was developed by Pittway and Watkinsons. So, it may be implemented by two persons, that is Pittway and Watkinsons. Okay, so the anti-aliasing the computing area is referred to as area sampling or pre-filtering. So a modification to Bresnam's algorithm was developed by Petitways. Based upon that Bresnam's, we can draw the lines. Okay, so Bresnam's and DDA, but DDA it cannot be taken the floating points in that way, but it's taken the point, but it maybe takes some time. In that way, we can go for the Bresnam's. We can write the perfect curves. In that way, if any aliasings occurred in that way, we are using to the areas post filtering or pre filterings. Okay, so in this algorithm, each pixel is given intensity depending on the area of overlap of the pixel and the line. So due to the blurring effect along the line edges, that the effect of anti-aliasing is not very prominent. So although it is still exists. Okay, for sampling say shapes other than polygons, this can be very computationally intensive. So based upon that, the sampling shapes other than the polygons కాకుండా remaining whatever the shapes are there, these are the very computationally intensive. In that way, we can using of the some aliasing techniques, based upon techniques we can draw the smooth lines, curves, whatever may be. Okay, see, in anti-aliasing that we have different type of the methods. The first one is the super sampling method, that is the super sampling method. Next one, area sampling. Next, filtering techniques. Next, pixel facing. In super sampling we can call as post filtering, and area sampling we can call as pre filtering. Next, considering zero line width. In the super sampling we have to find the three areas. The first one is the considering the zero line width, considering the finite line width with pixel weighing mask. So based upon these three, we can implement the super sampling, that is fold filtering. Let's go for the area sampling, that is the unweighted weighted. Based on that, we can assign the area samplings. Okay, so here these are the different type of the methods from anti-aliasing techniques, that is the super sampling. Next, area sampling. Next, filtering. Next, pixels. That's the pixel facing. Okay, so super post filtering, pre filtering, filter techniques. Next, pixel facing. Okay, in super sampling, this we have considered some zero line width and consider finite line width, can consider the weighting of the masks. This is unmask like that. Okay, mask technique. Then area unweighted and weighted. So it is called as the aliasing techniques. Both of these aliasing techniques we can based upon that we can draw the smooth curves. What is an aliasing? Whenever we can draw the lines, it may be jogged. That is the that maybe resolution is very low. In that process, we are using the aliasing techniques. Based upon these techniques, we can draw the smooth lines and smooth curves. Okay. So this is when applying another technique, we can draw the smooth curves likewise. Okay. So two methods, that is the super sampling or post. Next one is the area sampling or pre-filtering. These are the another two methods, filtering techniques and pixel facings. Okay. Thank you.